Hey, Sister Johns, Austin.
Calling again.
Hello.
Okay.
Baby.
Oh, and this is our homie,
This is Andy.
Andy. Okay, yeah, Harambe Bay.
Harambe Bay.
So we're just gonna go over our group props.
Props.
So guys, I'm feeling really depressed. So
Don't worry. I got you.
just kidding.
You're not depressed. You got into med school.
Yes,
I did not get in. I just had an interview.
Austin had an
You got
interview on Monday in Virginia for med school, and he basically got in.
Basically slayed it.
Hoping
Yeah.
so. It was really cool.
Yep. Hang on, I'm
I already got an apartment over there.
Yeah. Anyways, yeah, no, dude, it
Okay.
was super sweet.
super sweet.
Alright,
I'm
so
gonna draw out what I got
Wait,
Cool.
for what?
for number one.
You're gonna
Okay.
draw it out?
Yeah.
number one was the transcription in E. coli is subdivided into 3 stages, which are initiation, elongation, and termination. Portion A of that question asks what DNA sequences are involved in the initiation in E. coli.
So I put promoters, and it's the -35, -10, and +1 region, and then also the regulatory DNA sequences.
Oh yeah. That's what I did.
Sweet.
And the key says. Let me pull it up real quick.
It says the same thing.
Same thing.
Yep.
Oh, sweet. All right. And then B.
What proteins are involved in the initiation of E. coli?
What proteins are involved in the initiation? So, we got so sigma 70 or the housekeeping gene or housekeeping protein. Sigma 54, sigma 38, sigma 32, and then I did RNA polymerases 2 alpha subunits and 1. I don't remember. Is that the little W?
Wait, what? What are you talking about?
Yeah, you did a lot.
All I put was sigma factor and the RNA polymerase,
Okay. Cool. Yeah.
right?
Yep. That is correct.
Do we need to specify
So I
like
just did too
I don't think you have to specify
Which
which
areas?
sigma factors now. It just says which
Just-
proteins in the sigma factors.
Okay.
I like it.
B or C, proteins involved in elongation in E. coli.
The RNA polymerase core enzyme, right? The RNA.
Yeah. I put RNA polymerases beta and beta prime subunits, but I guess I didn't.
got the same thing.
I didn't have to be that specific.
Yeah.
Okay.
Just so good, Ben.
Thanks. D. What DNA sequences are involved in termination? Terminates.
So the RHO protein, right?
Wait, the sequences?
Oh,
though?
no,
The
not
sequences
in
is just
coli.
the Terminator DNA sequence.
Oh, for D.
Oh. Ooh.
Because we're not talking about proteins yet. For proteins,
Yeah.
we're
Or-
talking about the sequence.
Yeah. Terminator sequence. Yeah. So that produces the stem loop structure. Which serves to like slow down RNA.
Yeah.
Oh, right.
Slows it down.
And then E, which proteins? Then that's the row and the nusa.
Nuse.
Yeah, the nusa.
Yes. Cool. So
That's
number,
why.
number two, my lord. Number 2.
These are all.
Number 3, my lord. Number 3.
Number 2, my lord. Okay. E. coli produces a family of proteins called sigma factors. A. What is the function of a sigma factor?
So
I'm sick.
I'm sorry. I put it's a transcription factor. It promotes the transcription of different genes depending on environmental factors.
Preach. Nice.
But in the
Solution manual.
in the solutions manual,
Or
it says
Chem.
it says that it guides the RNA polymerase to the promoter, and I didn't see that anywhere in the thing, but
Yeah.
I-
To the -10 and -35 sequences.
yeah.
Cool.
Whoops.
All right. Yeah, I just said recognize the promoter and targets RNA polymerase to the gene. B, one of these sigma 70 is called the housekeeping sigma factor. What do you think housekeeping means? So I said, since it's required for transcribing all essential E. coli genes, if the cell is infected or damaged, it's what's necessary to build a brand new cell.
Okay.
Wait, what?
For B.
I
Sigma 70.
I just said that it's making sure everything is taken care of. It makes essential genes.
Basically the same thing.
Okay.
Solutions thing.
You're either bad.
No. So on the key, it says housekeeping refers to all cellular functions that are required for life. Therefore, the housekeeping sigma factor functions to guide the RNA polymerase core enzyme to the promoters of all genes essential for life in E. coli. This ensures that these essential genes are continually transcribed. So a little different. Big picture.
Yeah.
Very big picture.
Okay. What about C?
See? First, what'd you put, Colin?
It's a great question.
There's sigma factors. So there's the general starvation, nitrogen starvation, and excessive heat. The benefit of having multiple sigma factors in E. coli, I said that in case it encounters like extremes like lack of nutrients, lack of nitrogen, heat,
So like extreme
Ex-
nitrophiles,
yeah.
nitriles, whatever.
selenocytes, I don't know. Extremophiles,
Thermophiles, yeah.
Yep.
Yep.
I said
Yeah.
that those are they.
What? Why are you looking at me like that?
Your muscles are just so big.
No, they're not.
So wait. I just put that it allows different genes to be transcribed due to different environmental factors.
Yeah. In case it starts to get like denatured or something, those proteins or sigma factors will enable it to survive and keep transcribing.
Yeah. And then D. Enhancers, silencers, transacting factors, TF. All the TF.
Yeah,
ones.
that's what I did too. 2D, 2B, 2F, 2E, and 2H.
Include, yeah.
So it was all the eukaryote ones.
Yeah. Dope.
Yep,
Dope.
Did I
Super
forget?
dope.
Did I forget to do
Cool. Beans, cool.
I'm almost.
You already have one there.
Didn't I do it?
3B. Nope, you already have them all there. Okay, so we're on 3A?
Mhm.
3A, okay. So, it says we learned that E. coli terminates transcription using either the P-dependent or P-independent mechanism. So how are these two different?
Row dependent uses row proteins and RUT. Independent uses the NUC. That's what I put. Oh yeah, and I also put that the independent uses it like breaks the hydrogen bonds. Like it does something to use hydrogen bonds. I can't remember what it was.
Adenine and uracil?
Yeah, it does the hydrogen bonds between those two.
Yeah. So the uracil, it has fewer hydrogen bonds, so it dissociates.
Yeah.
Doesn't,
Yeah.
I'm so sick.
What are you staring at?
Sister Johnson, an antibiotic, I got you. Okay, where are we? Alright.
For the love of
Son of how are these two mechanisms similar?
Yeah.
Mm-hmm.
I put that both involve the formation of a hairpin loop to
Yep.
slow down RNA polymerase.
Yep.
And that's what the answer key said too.
Very nice.
High
I
five.
am the answer key.
I am the answer.
Just kidding.
Okay, for C. Suppose you are studying row-dependent transcriptional termination in the lab. Propose 2 ways you could interfere with the row-dependent transcriptional termination process. Think in terms of specific changes you could make to the DNA or mRNA that would inhibit the transcriptional termination. So I put, instead of using the deoxy GTP or deoxy CTP, we could use just regular CTP and regular GTP, and that would make the stem loop not form.
Oh, you got real technical,
I'll take a roll.
which I wish I would have. Because I just said that, I basically just said, like, okay, put different base sequences in, the ones that don't, signal for the formation of hairpin loops. And then, or excise the row utilization sites somehow.
Yeah, that's what she put, and I think that's pretty much the same thing.
Really?
Yeah.
Excuse me. Yeah. Okay, yeah. Mutations in the RUT sequence. Okay. So D. Excuse me. Yeah, change the terminator sequence. It said inhibit Nus A, prevent uracil-rich region in the RNA strand from being formed. Yeah. She said create mutations in the terminator DNA sequence that would change adenine-rich sequence in the template to a G or C. That way they would still like hydrogen bond. And also the stem loop formation.
Yeah.
So it doesn't really have anything to do with Nus A, apparently.
Nope. You dummy. Okay. For 4.
So 4, the DNA sequences required for basal transcription in eukaryotes. So I said the 5' to 3' tau sequence.
Mm-hmm.
The +1 site, the cat box. So I guess she just had the tau box.
Yeah, and the Tata box also includes. So the Tata box is the negative
Site
25,
group.
right?
Yeah.
And then the +1 site.
Core promoter. Okay. Sweet.
Hey, Mom. Yeah, I'm studying. I'm going over genetics. I'll call you back in a little bit.
So then B.
Okay. Yeah, I'll call you back in a little bit. Okay, bye.
What's your mom's name?
Lisa.
Sandy? Oh, Lisa?
Yeah.
Oh, so good.
Why? Why?
Good name.
Lisa.
Good name. Lisa.
Hey, Lisa.
Lisa.
Why? Why?
Lisa Mitchell.
Why'd you think? No, Lisa Wright.
Lisa Wright. Okay.
Yeah, my parents are divorced.
Not nice. 2 Christmases.
Sorry.
Sorry. Insensitive.
It's alright.
B. What proteins are required for basal transcription in eukaryotes?
RNA polymerase 2, TF2D, TF2B, TF2F, TF2E.
F.
Yeah.
Yes. I was a little confused on this one. I put.
Oh, 2FT.
I just put regulatory transcription factors.
Yeah, that's the same thing as the
Is it?
TFs. Yeah.
Okay.
Or wait. No,
General
it's not. No, it's not.
transcription
Sorry.
factors.
Yeah.
So I got that one wrong.
Yeah, you did.
Very wrong.
You missed the mark on that one, Ben.
Dang it again. Okay. My voice is going. Excuse me.
Okay, what DNA sequences are involved in regulated transcription in eukaryotes, enhancers, and silencers? That's what I put. And core promoters, so also all the TFs.
Yeah, I guess.
Oh no, the
It's-
Tata box. Sorry.
Core promoter elements. Is it specifically the top box?
Yeah, and +1 site. And also promoter elements.
Mm-hmm.
I didn't put promoter elements
You missed the mark on that one.
in there. Yeah, I did.
Do we need to include like the enhancers and silencers?
Yeah.
Probably all of them.
Which are part of the regulatory DNA
Yeah, dude.
Yeah, I gotta go to the tier 11. You help?
sequence.
No.
Activators and repressors.
Math lab or?
Well, I'm gonna go just talk to Alex Marble.
Yeah, Marvel.
Yeah, it's
Used
just
to live with him.
Oh, really?
Yeah.
Wait, what was your name again?
Ben.
Ben. Oh, yeah.
I lived with him for just
You-
one semester. Like,
At the Loft.
yeah.
Okay, I remember that.
Really?
I thought you were. I
Yeah.
hang out with them like all the time.
Really? They're good guys. Freaking Brock's taking like 23 credits this semester.
I know. And he
You're
took over
ill.
the 7-week break. He did like 19 just so he can.
Seriously?
He's graduating.
He wants to move though, I think. So.
But he was so hyped to get done, and then now he's just like, I'm 22 and I'm graduating.
I
Like,
can't even imagine taking 23 credits. Like, I'm at 14 or 15. I feel like I'm drowning.
I know.
But different classes. I mean, it's all hardcore
But
science.
he also just like eats 30 milligrams of Adderall every meal.
Nice. A healthy diet.
He's gonna die if he doesn't take it.
Yeah, dude.
All right.
Hey, later, have to see him.
Okay, for D, proteins involved in regulation.
For the D.
TF2H, TF2D, TF2B, TF2F, TF2E, the mediator, the RNA polymerase 2, activators, and repressors.
Okay. There's a lot in there that I missed. Like a lot.
What was that one for?
4D.
4D, right?
Yeah. Yes. And then 5.
40
what? What?
40 what?
40 what? Five, this question concerns the 3 major RNA modifications discussed in the lesson. So, first RNA modification is 5' end capping. So that's the guanine, right?
What?
Guanine cap
Wait, what?
on the 5' end.
What?
For 5A.
Wait, what'd you put for the first thing that happens?
Excuse me. 5' capping.
I put the splicing.
That's how it's listed, but it's actually 5' capping occurs first.
Oh.
Yeah.
And splicing is the last one?
Splicing is the last.
That's weird.
Yeah. I know you had to read pretty into it on the notes.
And then the second is the adding of the poly-A tail?
Yeah, polyadenylation. Yeah. So that kind of makes sense because then with the 5' end, so that means it won't be like degraded or anything in the cytosol when it's transported outside the nucleus.
Yeah.
Everything with the poly-A tail.
Okay, ribozymes play an important role in RNA modification. What is a ribozyme? I said it's a pre-mRNA that removes their own introns, and splicing is what ribosomes do.
Exactly.
Okay, definitions.
So snRNP or SNRPs, those are the ones that catalyze the enzymatic cleavages responsible for removing introns. So yeah, it's part of the spliceosome complex.
Yeah.
It contains the ribozymes. Okay, cool.
Guanosine nucleoside is a cofactor for self-splicing.
Yeah, that's all I found on it. CPSF is the cleavage and polyadenylation specificity factor. CPSF that cleaves RNA 10 to 35 nucleotides downstream from the recognition site.
Yep. Put 10 to 15, but it's 10 to 35.
Yeah.
Poly-A polymerase. I put attaches adenine to 3' end of transcript.
And one allele transferase recognizes and hydrolyzes GTP to produce GMP and pyrophosphate. It also attaches the 5' carbon of the GMP molecule to a 5' carbon on the nucleotide at the end of the transcript.
Yep.
Cool. So My picture that I did, I can draw it if you guys want.
Yeah, please. Yeah.
Oh, cool.
I don't know.
We're only. Can I borrow your marker?
I don't have any markers, Ben.
There's a marker up there, Ben. Excuse me.
I guess that, no, I could, well, yeah, just one.
What color?
Not red or black. So, green.
That's kind of racist.
I am a racist person. Just kidding. Not very. Okay.
Wait, you're not kidding?
So, a good, I don't know. I just used the PowerPoints thing. They had a good picture on there. Okay, so the coding strand, you're going to have a 5 prime.
Great marker.
Do you have a black one?
You said you didn't want my black one.
Okay, I changed my mind.
You want your black one?
You know what they say.
Once you go black, you always go back.
Something like that. Oh, yeah, that's a good one. So this is your coding strand.
Alright.
So coding strand.
Some Cody.
Cody strand. Have you seen that meme where it's like, bought a can of Axe to spray this spider, now its name's Chad, and he's chasing all the girls spiders around my house.
Yeah.
Oh man, that made me laugh. So then I did, so since it says it has 2 introns, I just took 2 regions, both of it, and did like this. So, oh bless you. Introns. And then 3 prime end. And then you have your template strand, which is also has the introns. Bless you.
Back to school.
Back to school.
To prove to Dad that I'm not a fool. I
Oh, back to school.
I got my
Introns.
shoes tight, my lunch packed. I hope I don't get in a fight.
Oh! And then this is your template strand. So then it undergoes transcription here, and it makes so trans grip should to make a mRNA pre-mRNA.
It's gonna make a P.
So, yes. It also has the introns.
Is he laughing? Nothing.
Introns. And
Trying to figure out if this has aspartame in it.
If it's 0, it should. Or at least some type of sweetener.
Sarge shared this article, the way it's like, that said basically aspartame is not bad.
It's not. The only thing about it is that it's just like not
Real?
degraded. It's not.
Yeah.
It's not degraded by your body. It's only broken down by your liver. It's not as bad as fructose though, which just creates a bunch of horrible byproducts.
Get it out, bud. Get it out.
Try. Okay, so then this pre-mRNA strand undergoes splicing. So it splices up complex, right? Which eliminates the introns from the strand. So then you get this nice, brand new, beautiful, mature mRNA strand. So then this all, so then you get, let's see, you have your 5 prime coding strand. got. Okay, so it still has its mRNA or its introns.
Oh, so sorry. Didn't mean to interrupt.
Okay. So then basically the intron get bumped up. Well, just squished together.
Take a
When the mRNA. Wait, I don't want to do that yet, actually.
Come here, Mr. Penguin. You need to go back to the zoo.
It's too dang high for a penguin. So then your mRNA strand. Template.
I love that movie.
Should have done that in red. I'm gonna go back and change this. Sorry, guys.
What did they play in? Marco Polo? Marco.
Okay. So then you have a nice brand new strand of mRNA. So then,
Man, am I glad I caught that guy.
so basically, I'm gonna erase the coding strand just so you guys can visualize.
Okay, okay.
Once it splits, so the mRNA lays across the template strand like thus.
Thusly.
RNA, and then its introns are basically squeezed up there, and the mRNA just kind of, I don't know, I visualize it like pinching it.
Pinch it off.
Exactly. So then, final product. So you got your coding strand. And you got your template strand. This is just the big picture, essentially the same thing. Take 5
What?
Same thing here. And there's your mRNA. Oh, wait, the coding
Have you guys seen all of these Joe Biden memes going around?
Yeah, they're so funny.
Dude, they are the best things
They're
I've
really
ever
funny.
seen.
Yes. Agreed.
Hey, who'd you vote for? I wrote in Harambe.
I saw somewhere that like 15,000 people did that.
Yeah,
It's pretty amazing.
it's stupid.
Yeah, it's pretty dumb, but it's kind of funny.
15,000 adult people got up, went to the polls, and wrote in Harambe.
Did you hear that Colin Kaepernick didn't even vote?
Yeah, he's in it. Did you hear what's his name? The ESPN guy.
Oh yeah, I heard he like ripped it.
Dude, he ripped him a new one. He was like, everything that guy says, he's like, I think the media needs to keep cameras off of him unless he throws a football. When he starts talking, don't even put the camera on him. he just went off. He was
That's
like,
hilarious.
he is so pissed.
Okay, so these are all.
What, was black?
What?
Is that guy black?
Who?
The one that ripped him a new one?
Yeah,
Okay, good.
yeah, it's that.
Okay, yeah, I was gonna say a white guy couldn't probably get away with that.
No, it's do you know who I'm talking about? That announcer guy? And Steven?
Stephen A.
Yeah,
Nice.
yeah, that's who it was.
That guy's fun.
Dude, he's
These
awesome.
are R loops. And then your introns, of course. So this is what I did. I don't know if it's right. Oh, I mixed it. I mixed the black. Oh no.
Obama didn't think he'd be late. Biden, I gave him the wrong address. Obama, Joe, he's the president-elect. Biden, ID gaff, what they call him.
I don't care. Okay, so that's what I did.
Can you explain that last part to me?
So, if I'm correct, my logic.
I get all the way up until the mRNA where it squeezes it. That makes sense. And then the coding strand, like what are all those loops that you?
So those loops are basically like.
Oh, is that it? Like coming, like pinching, so that way it can read. Oh,
Yeah.
okay. Those are our loops. Oh, okay.
From there on, I don't know.
That-
Did I borrow a resume?
No, just agree.
So I don't know. That's all that I could figure out from the PowerPoint.
That looks good.
Stuff.
KK.
KK.
Well, see you later, Sister Johns.
Bye. Have a good week.